Hello, my name is Boyan Brodaric, and on behalf of the GIN team, I'll present the Groundwater Information Network. The Groundwater Information Network, or GIN for short, is a national and international collaboration for sharing groundwater information online. GIN not only serves data from the Groundwater Geoscience Program, but it also links data sources from provincial and territorial agencies to create one unified system for groundwater data delivery. GIN is in its third program cycle, thus it is a continuing project, unlike the other projects in this current program cycle. As a result of this continuation, this talk will both discuss GIN achievements from the last program cycle, as well as objectives for this next program cycle. From a Canadian perspective, GIN is a national data network connecting heterogeneous and distributed data sources from 9 provinces and territories. The data network consists of 9 distinct themes, most notably aquifers, water wells, and monitoring sites, numbering in the tens for aquifers, the thousands for monitoring sites, and the millions for water wells. From an international perspective, GIN is also a node in a global groundwater data network that includes hubs in the US, Europe, and Australia. Its seamless connection with the U.S. hub, the U.S. National Groundwater Monitoring Network, allows for integrated data access between Canada and the U.S. Its participation in the IGRAC UNESCO Global Groundwater Monitoring Network allows it to play a key role in monitoring groundwater levels across the world. In addition to being a data network, GIN also provides a web portal for online access to its information within the network. Over the years, it has seen a steady and continuous stream of activity within the web portal, averaging over 1,000 users per month, more than 25,000 sessions per year, and more than 2,000 data downloads per year. The bulk of the activity occurs within Canada and the US, although access to the web portal does happen from all over the world. Access to data within the web portal and interoperability of data sources within the data network is enabled strictly through the use of international standards. Indeed, GIN has been a leader in the development of standards both internally and internationally, including data specification for groundwater geoscience program data, as well as the Open Geospatial Consortium Groundwater ML2 and Geoscience ML data specifications. The Groundwater ML2 specification is furthermore now a submission to the World Meteorological Organization, where, if accepted, it will become the data exchange standard between the WMO and all its partner agencies for groundwater. Another significant achievement is the reuse of the GIN platform for the Permafrost Information Network, which is an analogous data network and web portal for permafrost information in Canada. In its role as a groundwater data innovator, GIN is also exploring new directions to groundwater interoperability, primarily involving linked data. Linked data not only allows access to individual data sets, as per previous technologies, but it furthermore allows connections between data sets to allow, for example, a gauging station to be connected to a stream network, to be connected to an atmospheric gauge, to be connected potentially to an aquifer. Such connections are important because they allow data to be linked for a complete view of the water cycle, thus enabling integrative water science. To achieve this integrative vision, GIN has been participating in a number of linked data projects. The overall goal of these projects is to develop a common, comprehensive, and web-based platform for all water data. The projects include a cross-border pilot between the USGS and NRCan in which groundwater and surface water data are linked, as well as a project within the Federal Climate Change Science Plan, and 2 Open Geospatial Consortium interoperability experiments, ELFI1 and ELFI2. Results of the linked data projects have not only led to increased connectivity between water data within test areas, but also to increased discoverability of GIN data overall, particularly within search engines. For example, typing aquifers in Canada into Google Dataset search will result in GIN layers showing up as top results within the search. To wrap up the GIN highlights as a research item, The activities within this item not only underpin the highlights discussed thus far, but also lay a foundation for future activities. They include a reconceptualization of water features, which has influenced the data standards used in GIM. It also includes the shift from the spatial data infrastructure technologies to the linked data approaches, as just discussed. Now, shifting from past achievements to current activities, there are 5 areas of focus for the GIN project within the current groundwater program cycle. These include the development of a new web portal, particularly a new user interface and enhanced mapping engine, the development of a renewed data network that will allow new connections between partner datasets, the development of an Internet of Water building on linked data approaches for a comprehensive platform for all water data, as well as the advancement of standards to support all of the above, and the continuation of research to influence the standards. Plans for the new web portal include not only a new user interface as well as an advanced mapping engine, but also new tools to help analyze groundwater data. Amongst these tools is a 3D and multi-parameter water well viewer, as well as an aquifer dashboard to summarize all available information to GIN for an aquifer. It also includes a water level calculator, which provides multiple perspectives on the water level within a single well and between multiple wells. Progress on all these fronts varies, as shown in the slide. Objectives for the data network revolve around treatment of various data issues. These include the renewal and modernization of the connection between partner data and GIN to allow for more ready assimilation of updated, missing, and real-time data. It also includes support for the PIN project, including both technical developments as well as external partnerships, such as the Canadian Permafrost Network. Advancement on all these fronts is proceeding, as shown in the slide. A major thrust for this edition of GIN is the deployment of linked data services in support of an Internet of Water vision, whose goal is the development of a comprehensive online platform for all water data. A recent survey at an NRCan workshop showed that there was strong support within the water community for such a vision. For its part, GIN will continue to work with U.S. collaborators to deploy and advance linked data technologies to allow linkages of all kinds of water data across the U.S.-Canada border. GIN will also work on underlying semantic linked data technologies to further this vision. As this activity is essentially a continuation of previous linked data activities, all aspects of it are already in progress. The success of the GIN project is entirely due to its past and present contributors. The current roster includes myself, Eric Boisvert, Eric Julien, Francois Letourneau, Etienne Girard, and Joost van Olden, as well as the numerous collaborators nationally and internationally. For more information, please contact any GIN member, including me, at boyan.brodaric@canada.ca. At this point, I'll just wrap up with a final thanks for your attention.